Welcome everybody at the Gradle 1.0 Power Features. It's a part 2 of this webinar. We are at Gradle 1.2. That's the official release now. So I guess, and I'm going to be covering the power features that have been improved in Gradle 1.2. So I guess the name of the webinar is slightly out of date, but let's not worry about it. Let's move on. So I'm Szczepan Faber. I'm a host today. I'm a developer at Gradle. You might know me from my work at Multiproject. It's a pretty cool mocking framework for Java. If you haven't used that yet, well, that's a shame. You should have. So there you go, Power Feature version 2. I'll start with the IDE integration and things that we've added in Gradle 1.0 to improve the way to work with Gradle projects in your IDEs. I'll discuss the DSL extensions, very useful for plugin development. I'll talk about Gradle daemon, and I'll talk about monitoring code quality. I'm not going to cover all the code quality plugins, but I'll cover the way they work in Gradle. So with the help of the user guide, you can work with other code quality plugins as well. So let's get started. I'm going to start with the idea plugin, and we will also have a deep dive into the concept of an onion skin API. And if you are an Eclipse user, don't worry. I'll cover Eclipse pretty soon. I'll be showing the STS Eclipse integration, which is a different kind of plugin that integrates your Gradle projects with IDE. But right now, what I want to show and demonstrate various features of the idea plugin, that is a built-in plugin in Gradle that allows you to generate the metadata that later can be used to import the project into IntelliJ. And again, the example is based on IntelliJ. However, we also have an Eclipse plugin also built in that can generate the metadata that then can be consumed by Eclipse. And this plugin works pretty much the same way, all right? It has the same mechanics, the same workflow, the same gotchas. The only difference is that the model is slightly different. The way you configure it is slightly different because Eclipse view of the world is different than IntelliJ's view of the world, all right? So let's get back to my demo. All right. So I have a really small project. It is a Java project. It only applies a Java plugin right now. It also uses the wrapper. In the source folder, I have a small Java class. All right. And this should be, before jumping into details, I'm going to make this project wrapper aware. So I'm going to run the wrapper task so that it'll generate the wrapper configuration for me. And now I can do Gradle. I can use Gradle W to run Gradle in this project. As you can see, it's using 1.2 exactly as the way I configured it in my build script. And I don't want to go into too much details of what a Gradle wrapper is. We have a dedicated screencast for that on our Gradle.org pages. Suffice to say that you definitely want to use Gradle wrapper in your team because that guarantees consistency across the team members. They are using the same Gradle versions to build the software, and consistency is a good thing. It makes us happy because there are less bugs and problems. All right. So I have a Gradle wrapper. The first thing I'm going to do is I'm going to apply IntelliJ plugin. It's the idea of this plugin is idea. You can, and this is this plugin that generates the metadata that can be used to import to idea. So let's do Gradle tasks. Now you should see that we have the IDE tasks. Clean idea and idea tasks are available. So let's generate the idea metadata. After that, when I ls the contents of the directory, you can see that there are the metadata files generated, and now I can open this project in IntelliJ. So let's just do that. Webinar IPR. I've just opened it in my IntelliJ. So it's there. I have a build.gradle. I can work with that. If I go here, there's a demo Java class. So the class is properly, so the project built in IntelliJ. If I make a compiler problem here, it's going to fail in IntelliJ, and it should also fail in Gradle. When I try to build this Java project, the compiler complains. So let's make the compiler happy for now. And let's spice up the example a little bit. So this is the basic mechanics of how it works. All right, you have a Gradle project, you apply the idea plugin, and then you can generate the metadata, and then you can import to IntelliJ where you can work with that. Okay, if I wanted to use an Eclipse plugin, I could do something similar. I could do something like that. I'm applying an Eclipse plugin. I also have now ways to generate the Eclipse metadata. And it's pretty okay to have both of those, IDEA and Eclipse. This is the case in our Gradle project. It means basically that some team members work with Eclipse and some team members work with IDEA, so which is fine. In my example, though, I'll be focusing on IDEA for this kind of plugin. Eclipse will come later. Therefore, I removed the Eclipse part from it. I want to make this a little bit more interesting. So let's add some complexity to the build, and then I'll be going deeper into the API of the IDEA plugin. All right. So let's make the project use some third-party dependency. All right. So I'm gonna add the repository. It's gonna be a Maven Central. I'm gonna add dependency. I'm gonna depend on commons lang, and now I don't remember what was the version to use. I think it was 2.6. We'll see. So I've added some dependencies. I'm gonna now run Gradle W dependencies task to see if this resolves fine. There you go. The commons lang has been properly resolved. Now, in my demo class, I can't yet use those classes from that extra library. If I expand the external libraries in IntelliJ, you can see that it's only 1.6. That's the Java version that I'm using right now. So what I need to do is I need to regenerate the IntelliJ configuration, and basically that's the default workflow. You make the changes in the build script, you regenerate the IDEA metadata, IntelliJ asks you to reload, you reload, and now as you can see in the external libraries we have commons lang library, so we can use it in our Java code. So let's just do it, and we can use, for example, string utils, normalize space. So let's denormalize a little bit space to see if it works. I can just run it. As you can see, the spaces has been normalized, so I'm able to use a third-party library. Okay, this should still build. If I do Gradle W build, the project still builds. When I run the IDEA task, okay, you might have noticed that there are actually a couple of tasks that have been run. So the IDEA module, IDEA project, and IDEA workspace. So the reason for that is that separate tasks generate separate pieces of the configuration. They make up the intelligent metadata. So there's a separate task that generates the module information, separate task that generates the project information. And those tasks are basically modeled in a way IntelliJ wants them to work, right? Because in IntelliJ you have a concept of a project, you have a concept of the module and a workspace. Okay, so let's complicate that even more. All right, so I'm gonna make it a multi-module project. So let's do settings.gradle. Settings.gradle is a standard way in Gradle to configure a multi-project build. Let's have a two-project impl and API. Now I want to show you the topology of my project. So Gradle projects now should show me we have a webinar, a root project, we have an API project, an impl project. So let's shuffle the code a little bit so that this topology actually makes sense. So I'm going to mcat there the impl directory where the project impl will live. I'm going to move the source from the root project into impl. I'm going to also create the directory for the API project. Now, I need to go back to my build.gradle. I need to change it slightly because now I have multiple projects. I need to configure them properly. So here's what I'm going to do. All right. I'm going to make the all projects apply the IDEA plugin. All right. So every project uh, will have to apply the IDEA plugin. I'm going to make only the sub projects apply the Java plugin. And the reason for that is that the root project is pretty much some kind of a wrapper directory that contains all the other projects versus so it does not have to be a Java project. It's just a project. Hang on a second because I see that I have some questions. So let me quickly see. So the first question was, is it possible to get a report of dependencies? Yes, it is. So I've run the Gradle dependencies tasks that showed me my dependencies. This is very simple now, as you can see, but normally in the real life project, you would see a tree of dependencies because Gradle resolves the transitive dependencies. And the next question was whether the dependencies report contains the information about the repositories that dependencies are coming from. No, it doesn't. So by default, the dependencies report only shows the dependencies. It does not show where does the dependency coming from. But it's actually interesting feature request. So if you can throw that to our forums, we'll definitely discuss that. Okay. Okay, let's move on then. Where were I? Okay, I'm setting up my multi-project build. Okay, I'm gonna also make all my sub-projects. My sub-projects, remember the topology. My sub-project is the API and the implementation project. They're also gonna both will use the Maven Central, and only the impl project will use the common slang dependency. All right, I will leave the task wrapper alone. It does not really matter for that case. All right, I think that should pretty much work. Let's first see whether my Gradle build actually works. As you can see, it builds. It first runs some stuff for the API project, and then it compiles for the impl project. Let's see if I can generate the IntelliJ configuration easily. We can. So reload project. When I reload it, you can see that IntelliJ now reflects the topology of my multi-project build. So the webinar is the wrapper with some kind of a outer project, a parent project, and then we have an API project and an impl project. Both of them are Java projects. All right. Let's add a interproject dependency to make it even more fun. So I guess the easiest way is if I create the API. I want to create a folder, the source folder for the Java code for the API project. So API, C, main Java. Now I can do Gradle IDEA module. So now I'm shortcutting a little bit. I'm not running all the IDEA task, which in turn does the IDEA module, IDEA project, IDEA workspace. I only run the IDEA module tasks because I know that I've just created a source folder, and this is the source folder is a modal element of the module, so I can just regenerate the IDEA module information, and now the API project should have the Java source folder. And as you can see, it's annotated in blue because it's a proper source folder in IntelliJ. Don't worry if you're not sure yet what is the difference between various IDEA tasks. If you are not yet familiar with that, you can always run Gradle W IDEA. This is the safest bet. Okay, if you are a little bit more advanced, experienced users, you know which task to run. IDEA module is running only IDEA module is sometimes also useful because it does not the IntelliJ will not ask you to reload the project. Okay, we will apply the changes behind the scene, which is pretty cool because it's pretty the turnaround is faster basically. Okay, let's add a class. Actually, I'm going to add an interface, demo able. It's an interface. It's going to have a string demo method. Oh, actually, I'm going to move it to some kind of a package because it does not. I don't like classes. hanging around in a default package. Yes, yes. All right. I'm gonna make demo implement the demoable. Demoable. Um, it's not working, right? Because demo lives in a separate project. This separate project on its class path does not have access to the demoable. If you ask IntelliJ what is the resolution to that problem, it's gonna tell you, well, let's add a dependency on module API. And we could resolve that problem this way, but it would only resolve that problem in IntelliJ, which is not what we want. We want Gradle build to work fine, and we want the generated metadata from the Gradle model to contain that information. Therefore, we're going to add the dependency in the Gradle level in the build script. So compile dependency on project API. Now what I'm going to do, again, I'm going to shortcut and run idea module, which should do the proper inter-project dependencies for me. If I go to dependencies, you can see that now the impl module in its dependencies tab contains the API project. So we applied the idea plugin, and Gradle figure out that there's a Gradle project dependency on a separate on a different subproject. Therefore, this needs to be reflected in our IntelliJ configuration. If I go back to my demo, now IntelliJ can offers to import that class so that we can use. Okay, let's make the compiler happy. Let's just implement the demo method. I'm gonna just return the message. In here, what we're gonna do, we're gonna print line new demo. It should work exactly the same, but as you can see, the inter-project dependency are nicely reflected in IntelliJ. We should also be able to easily build the entire Gradle project. It works well. Okay, so okay, let's make it even more fun. Let's make it even more interesting. What I'm going to do now is I'm going to add a little bit more of the IntelliJ configuration here. Okay, so in IntelliJ, there is a way to configure the project language level, which means it's yeah, everyone knows what it means. And by default, the language level is inferred by Gradle. So usually you can just apply the plugin idea, and the Gradle idea plugin will figure out what should be the target the language level based on your Java settings, based on sensible defaults. However, just for the sake of this demo and example, let's assume that we want to reconfigure that and we want to change that. And you can do that easily. So if you have some unconventional setup and you need to configure some extra stuff in IntelliJ, you can happily do that in Gradle. So for that, you can refer to the Gradle IDEA plugin. Let's go to Gradle IDEA plugin. It has a bunch of documentation how to do that. It also specifies how to configure things. So let's take a look how we can configure the IDEA project. You see in our DSL reference, we even have a code samples how to configure things. And one of our code sample actually demonstrates how to configure the language level. So let's steal that sample and let's configure that. So the idea project, I'm reducing the closure configuration because it's a simple thing to do. So I'll just do that. Language level 1.5. Also, if you noticed, I don't configure this language level everywhere because I want to configure this language level on the project level. And in IntelliJ, you have a single project that is attached to the root project of your build or Gradle. So let's see if it works. Remember before we have right now in the project we have a project language level configured to Java 6. All right, I've just configured the language level in my build script to 1.5. Let's generate the let's regenerate the idea metadata. There you go. Yes, please reload. Now, if I go to my settings, as you can see, it now the language level is set to Java 5. So this is an example where we use our configure where the IDEA plugin offers some ways to configure the way your project integrates with Gradle. Your Gradle project integrates with IntelliJ, obviously. Let's refactor and let's add more complexity. Okay, so I'm adding more and more IDEA-specific configuration to my root build.gradle. I'm not a great fan of that. Let's keep let's separate this build logic into a build script plugin. Okay, so I'm going to apply from IDE.gradle, which is a file that does not yet exist, but I'll just going to create that. And my IDE.gradle will contain all the configuration related to the IDE. Right now, it's only IntelliJ, but that's not the case. It might be an Eclipse pretty soon. This should still work. I can rerun it. It should still work fine. Yes, it's all good. So what to do next? Okay, let's assume that the webinar project is a Git project. Okay, and let's see what happens if this project is actually versioned. So I'm gonna init the Git repository here. So as you can see, I have a Git working here, bunch of files that are untracked yet. If I go back to IntelliJ, it complains that, hey, I've detected a git root here. What's going on? So again, IntelliJ asks you to manually configure that. That's not what we want to do. All right, we want to make sure that our build script contains the IntelliJ configuration and all the logic that is needed, so that when someone generates the metadata, there are no errors like that. Everything smoothly imports into IntelliJ, and the developer can just start working. Okay, so let's make that happen. The VCS configuration is not something you're going to find in the top level configuration DSL. So if you look how you configure the Gradle project, there's no VCS stuff here. If you look how to configure the IntelliJ module, also there's no such thing right now. All right, so we need to actually do something slightly different. We need to use a slightly lower level API to configure that. Okay, so I'm going to use so if you look at our DSL reference, you're going to see for the IDEA project configuration, first you're going to see what are the top level configuration entries that you can do with nice declarative configuration. If you scroll down a little bit, you're going to find a more advanced configuration using some hooks. So basically what we want to hook, we're going to hook into the generation of the XML, all right, when the IPR file is generated, the metadata is generated, and we're going to manipulate it so that the VCS configuration is ready for us. Okay, so I'm going to cut the webinar IPR project. As you can see at the very bottom of that, there is some XML configuration of the VCS directory mapping. Okay, so let's try to configure that. So I'm gonna copy that. Okay, let's add the necessary closures. Now I'm gonna configure it a little bit. I don't need that many closures here. I can do things like that. So I can open the closure here. We're gonna configure the language level on the IDEA project, and we're gonna configure the IPR. I need to get rid of one brace. So I want something like that. So I'm configuring the IDEA project. I'm setting the language level. I'm also configuring the IPR. The name comes from the extension of the file that that contains the metadata for IntelliJ. It's a .ipr file. And with the XML, so just before the XML is written to the IPR file, we're gonna hook into and we're going to manipulate that. Okay, So let's do something with this XML node. I'm going to use a standard ways of manipulate XML in Groovy, so I'm not going to jump into the too many details how it works. It's a standard way of doing these things in Groovy. So I'm looking for the VCS config in the node component find. So I'm finding a component with the name VCS directory mappings. It name, is it lowercase? It is, equals VCS mapping. Let's just print it VCS config so that we can debug it a little bit and see if it's working. So Gradle W idea, it works. As you can see, the component is printed and as you can see, I've correctly managed to find it. So I don't want to reload at this time. Let's manipulate it. What I'm going to do is I'm going to configure the mapping to have a VCS of Git. Okay, so VCS config mapping, the first mapping, and then the VCS property is going to equals Git. Yes. And now and note that my project in IntelliJ is not versioned yet. At least IntelliJ does not know anything about it. And we're going to find it because there's going to be an additional button here which shows the changes. So let's go back to command line. Let's regenerate idea metadata. Our XML hook has manipulated the IPR XML. So if I cut the webinar IPR project, we could see that the VCS directory mappings now contains the Git entry here. And if I reload that in IntelliJ, I no longer have the red error here. And I also have a changes button. So basically now IntelliJ knows that this is a Git project. It offers to add those untracked files to the repository. So um, so that was an example of using a lower level hooks like the XML to manipulate the content. And I'm sure you see it now that this is quite powerful. You have at first layer, Gradle is trying to be smart and tries to figure out all the defaults for you, and you can just apply the plugin. If you happen to need to configure something extra, you have a DSL configuration for that, like language level. And if there is something pretty specific for your case, then you can still manipulate the XML content of the metadata to add whatever fancy automation for whatever unconventional use case you have. So this is pretty powerful. Let's go back to the documentation. You might notice that we have a with XML hook here, but also something interesting down the bottom. So before merged and when merged. So let me explain how those before and when merged hooks work. Okay. So before going to that, I want to explain the concept of merging. Okay. So when you run Gradle idea, okay, it does not mean that Gradle will completely rewrite from scratch the metadata files. Actually, Gradle tries to smartly merge the existing content of the files with the Gradle model. And the reason for that is that we want to support manual configurations should someone need that, okay? And let me show you an example, all right? So let's assume that I have a directory here that is called my stuff. I want this my stuff to be gone from IDE. I don't want it to be visible here. I want it to be excluded from IntelliJ searches and etc. The way to do that is mark that my stuff folder as excluded. So I have marked this my stuff folder as excluded. Okay, now you can see that it has disappeared from the module here. Now, you could think that when we now regenerate the idea metadata, you know, maybe my manual configuration here has been overwritten, right? But it isn't. Gradle is smart enough to know that to merge those things, all right? So if I reload the project, my stuff folder is still excluded, okay? If you wanna, obviously, if you wanna enforce complete regeneration of the metadata, you wanna drop all the modifications, you are happy, you are free to do so. You can do clean idea. So we've done first the clean idea task, which basically cleans the module information project metadata, and we generated it again, effectively writing that from scratch. If I reload that in IntelliJ,